Hello there. In this video, we'll be dealing with examples on one-sided limits involving the greatest integer function. But first, recall that one-sided limits is a type of limit that is only concerned with the behavior of f as x approaches a from either the left or the right side. Let's have this graph as an illustration. As x approaches a from the left, the value of f of x is represented by this limit here. Similarly, as x approaches a from the right, the value of f of x is represented by this limit out here. Now that this is out of the way, let's dive into a little bit on greatest integer functions. So to start, the greatest integer function is represented by this symbol out here, or sometimes we see it denoted by this double bracket or even this square bracket without the top part of the bracket, square bracket. And the reason for this is that sometimes the greatest integer function is called the floor function, since the idea here is like we are rounding down. So related to that, in the greatest integer function, what we do is that we output a value wherein this value is considered the greatest integer of x, or the greatest integer present or possible in x. So to have an example, let's try to find the greatest integer function of 1. Since 1 is already an integer, then the greatest integer present in 1 is 1 itself. So it's just a trivial case, but what if we have 1.1? Well, take note that 1.1 can be divided or split into 1 and 0.1. And in this one, the integer part out here is 1. And there's no integer in 0.1. So the greatest integer present in this one is 1. Simple as that. So as you can see, it's like rounding down. Let's have 1.65. What is the greatest integer of this one? Again, we can split 1.65 into 1 plus 0.65. And there is no integer out here. But this one is an integer. So the greatest integer present in this one is 1. So clearly it's just like rounding down, and despite how close the value gets to the next integer, like in this one, it is really close already to 2. But since the greatest integer present in here is just 1, then this is just equal to 1 as well. To understand this better, let's try to check out its graph. So this one that we have, as you can see, these are values between 1 and just before 2. So that is around this part out here, and the value is this one. So if we plot that one, it would look something like this. So as you can see, it's like a straight line. It definitely is a straight line. But in here, x equals 1 is included, and x equals 2 is not. So that is the idea for greatest integer function. It's like this. And actually, if we continue this, it would look something like this. There. So if you try to check out the values from other parts out here, the graph would look something like this. So it looks really nice, I think. And given this graph, we note that the greatest integer function is also sometimes called the stepwise or the staircase function, since its graph looks like stairs. Yeah. And to further understand this better, so we now have a graph. The question is, how do we express x in terms of something that we know? Particularly, take note that we can express the greatest integer function in terms of piecewise function. So that is, we can write this one as this piecewise function out here. So as you can see, this part out here is what we obtained. This one out here. For the next one, we get 0 if x is from 0 to 1. So it's this part out here. And so on. This goes and extends to infinity. So from this one, we can derive this. So the greatest integer function of x is equal to an integer n if x is from n to n plus 1. So what this tells us is that the greatest integer function is equal to the integer and just before the next integer. So this one is the next integer. And if we try to apply this one out here, so we plug in 1 out here, this will be 1, and 1 plus 1 is equal to 2. Like that. So x is equal to the integer before it out here, and all the values just before the next integer is equal to the previous integer as well. So something like that. So yeah, I hope you got that one. So this is the greatest integer function, and we'll try to explore it more through some examples applying limits on it. So let's start with the first example. We're tasked to find the limit as x approaches 1 of the greatest integer function of x. So before we start, feel free to pause the video so that you may try this one first on your own. Okay, so let's start. So first, let's try to inspect the values of the greatest integer function. So that is, we'll try to write out its piecewise function. So let's try to check the values close to 1. So we have 1, 0, and negative. Okay, so in here, again, since our focus is the values as x approaches 1, so it would be these values out here. And since we have a piecewise function, we'll be needing to check the limit from the left and the right to be accurate. So starting with the limit as x approaches 1 from the left, then that would be values less than 1, but close to 1. So it's this one, since we have this. So we know that the limit for this one is just 0. Similar processing, we try to find the limit as x approaches 1 from the right. So again, these are values greater than 1 but very close to it. So this one. So the greatest integer function of x is equal to 1. And since these two are not equal, we then conclude that the limit does not exist. So that is how we obtain the limit for a greatest integer function. Let's try to move on to the next example. We're tasked to find the limit as x approaches 3 from the right of the greatest integer function of 1 minus x plus x. So again, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's start. So again, let's try to check out the values of this greatest integer function out here. So we have the greatest integer function, or the greatest integer function of 1 minus x, is equal to this piecewise function out here. So let's try to inspect certain values in this many values, or this infinite values of this greatest integer function. So we have this. So let's try to inspect this one, and you'll see the reason why we chose this later. So we have this greatest integer function to be equal to -2 if this one out here is inequality holds. So the idea here is that we have x is equal to n again if x is from n to n plus 1. And this expression can be replaced with other expressions such as this one. We used 1 minus x, so we have 1 minus x. So then if 1 minus x is equal to like that one. So this is the idea out here. So we just replaced x out here with 1 minus x. And here, let's try to simplify this inequality out here. So simplifying, let's try to move that one out here. Here, so our goal is to have x in the middle. So we'll have, first let's subtract 1. So we'll have -3, this will be -x and -2. Then we multiply -1 in both sides of the equation to get 3 is greater than or equal to x. That. So it would look something like this. So we just reverse that one. And when we do the same process for the next one, so we'll have here, let's subtract 1 out here. So we'll have -4, -x, and -3. Multiply -1 both sides, and we'll have 4x here and 3. So it would look something like this. So as you can see, we chose these values out here since upon simplifying this inequality, we'll end up with this 2 out here. And since our goal is to check the values as x approaches 3 from the right, so we focus on values out here wherein the 3 would appear out here. Since our goal is the values as x approaches 3 from the right, so these are values greater than 3 but very close to it. So greater than 3 but very close to it, so that would be this one. So we'll use this value to get this limit out here. So we'll have this limit to be equal to -3 plus x. So as you can see, we just replaced this with -3. And since this is just a simple polynomial equation, we can simply plug in 3 out here to get 0, and so the limit is equal to 0. This is our final answer. So I hope you got that one right. So let's move on to the last example. In here we have the limit as x approaches 1/3 from the left of the greatest integer function of 3x minus 1 minus 3x all over 3x plus 1. So again, feel free to pause the video so that you may try this one first on your own. Okay, so let's start. So again, we first focus on this one out here. So we'll have the greatest integer function of 3x minus 1 is equal to the piecewise function. And again, let's choose certain values that we'll be needing out here. In this case, let's choose 0 and -1. So simplifying these inequalities, so we'll have here there. So let's add 1, and we'll have 1, 2, there. Dividing 3 in this inequality, and we get this one out here. Similarly for this one, so we start by adding 1 out here. We get 0, 3x, and 1. Divide 3 in this inequality, and we get this. Since our concern is, or are the values as x approaches 1 over 3 from the left, so these are values from the left of 1/3, so that those are values less than 1/3 but very close to it. So that would be this one. Since this x is less than 1/3. And so we take the value, this one. So we'll plug it in out here. So we'll have here -1 minus 3x all over 3x plus 1. And in here, observe that we can factor the negative out here. So we'll have 1 plus 3x, and by commutative, this would be 3x plus 1. Dividing these two, and we get -1. And since this is just a constant function, the limit for this one is equal to -1. This is our final answer. So I hope you got that one right. And as you can see, understanding the greatest integer function is important in the concept of one-sided limit, since again, its graph is something like this. So there's a lot of parts wherein the limit from the left is not equal to the right, like this part. Limit x approaches a from the left is not equal to, so something like that. So that is why we incorporated the idea of greatest integer functions in our study on one-sided limits. So to formally end this, here's an exercise that you can work on. So in here, we're tasked to find the limit as x approaches 2 of x squared minus 4x plus 4 all over x minus the greatest integer function of x. So to solve this, the process is just similar to our 3 examples. We first inspect the piecewise function for this one and try to check the limit as x approaches 2 from the left and from the right. So if you need help, just comment down below what parts you are confused in the solution for this one, and I'll try my best to reply to those comments or questions. So yeah, that's it. I hope you enjoyed and learned a lot from this one. Apologize for the cough, my cough. Yeah. So yeah, I hope you enjoyed and learned again. So yeah, that's it, and that's all for this video.